We're going to walk through 4 examples where we are going to identify and classify ordinary and singular points of a second-order ordinary differential equation. To make things easier, I've written down 5 steps that we can follow, and we'll go through these steps one by one as we walk through each example. Our first example is y double prime plus the quantity x squared plus 1 times y prime plus e to the x times y is equal to 0. The first thing that we want to do is put our equation in standard form. Up here on the right in green, I've written down what it looks like for an equation to be in standard form. There needs to be a 1 that multiplies y double prime. Notice in this example, we do already have a 1 that multiplies y double prime, so this equation is already in standard form. The second step is to identify p of x and q of x. P of x multiplies y prime, and q of x multiplies y. In this equation, p of x is equal to x squared plus 1, and then q of x multiplies y, and that is equal to e to the x. In step 3, we need to find where p of x or q of x is not analytic. P of x is a polynomial, and polynomials are analytic everywhere. So we'll say that p of x is analytic everywhere. Q of x is an exponential function, and exponential functions are analytic everywhere because you can write them as a Taylor series. So let's just write down that this one is also analytic everywhere. Step 4 is to classify the points as ordinary or singular. Because p of x and q of x are analytic everywhere, we have no singular points. So what we have to say is every point is an ordinary point. Now let's look at our second example. The first thing we're going to do is put this equation in standard form, so we are going to have to divide each term by x squared. This gives us y double prime plus 1 over x, that multiplies y prime, plus 1 over x squared times y is equal to 0. In step 2, we write down what p of x is and what q of x is. P of x, that's the function that multiplies y prime, and that's 1 over x. And then q of x multiplies y, and that's 1 over x squared. In step 3, we need to find where p of x or q of x is not analytic. P of x and q of x are functions where we have an x in the denominator. This means that these functions are undefined at x is equal to 0. So because of this, they are not analytic at x is equal to 0. So let's say that p of x and q of x are not analytic at x is equal to 0. And because of this, x is equal to 0 is a singular point. Now let's look back up at step 5 because we're going to have to do step 5 for this example. For example 1, we didn't have to do it. Step 5 tells us that if a point is singular, we have to determine if it is regular or irregular. To find if a point is regular or irregular, what we have to do is multiply by x minus that point. So in this example, we have x minus 0, and we need to multiply that by p of x. This gives us x times p of x, which is 1 over x, is equal to 1. This function is analytic at x is equal to 0. Now we have to check x minus a, which is x minus 0 in our case, squared times q of x. This is x squared times 1 over x squared. That is equal to 1. So just like before, we say that this function is analytic at x is equal to 0. Because both of these functions are analytic at x is equal to 0, and x is equal to 0 is our singular point, we say that x is equal to 0 is a regular singular point. And let's go ahead and highlight that. All other points are ordinary points. Let's now look at our next example. I chose 4 examples because each of these examples is different. The first thing we're going to do is put the equation in standard form. So we're going to divide by x minus 1. This gives us y double prime plus 1 over x minus 1 times y is equal to 0. In step 2, we find p of x and q of x. Remember, p of x is the function that multiplies y prime. We don't have a y prime here, so we could just think of this as 0 times y prime, so we can say that p of x is equal to 0. And then q of x, that's the function that multiplies y, and that's 1 divided by the quantity x minus 1. In step 3, we need to look at where p of x and q of x are analytic or not analytic. P of x is equal to 0, so that is an analytic function. So let's just say p of x is analytic. And now let's look at q of x. Notice that if we set x equal to 1, q of x is undefined. So we say that q of x is not analytic at x is equal to 1. So in this example, we have one function that's analytic and one function that is not analytic. In step 4, we need to classify our points. Since q of x is not analytic at x is equal to 1, we say that x is equal to 1 is a singular point. And then let's also say that x not equal to 1 are ordinary points. Now what we need to do in step 5 is classify this singular point at x is equal to 1. To do that, we have to multiply by x minus a, so in our case that's x minus 1 times p of x. This gives us x minus 1 times 0, because p of x is 0. So that's 0. So this is analytic at x is equal to 1. Now let's look at x minus 1 quantity squared times q of x. This is x minus 1 squared times q of x, which is 1 over x minus 1. So this gives us x minus 1. This is a polynomial. So this function is also analytic at x is equal to 1. Since this function and this function are analytic at the singular point x is equal to 1, we can say that x is equal to 1 is a regular singular point. So our solutions are x is equal to 1 is a regular singular point, and when x is not equal to 1, all of those points are ordinary points. Let's now look at our last example. The first thing we want to do is put our equation in standard form, so we're going to divide by x. So we have y double prime plus 1 over x cubed times y is equal to 0. Second step is to find p of x and q of x. Just like in example 3, p of x is equal to 0 because we have no y prime term. And then q of x is equal to 1 over x cubed. Now let's talk about whether or not p of x and q of x are analytic. P of x is a polynomial, so it is analytic everywhere. Now let's think about q of x. Notice that q of x has an x in the denominator. So q of x is not going to be analytic at x is equal to 0. So we'll say that this is not analytic at x is equal to 0. Now in step 4, we need to classify our points. Since q of x is not analytic at x is equal to 0, we say that x is equal to 0 is a singular point. And then the points x not equal to 0 are ordinary points. Now for our last step, we have to classify the singular point as regular or irregular. To do that, we have to look at x minus a, so that in our case, we have x minus 0 times p of x. P of x is 0, so this is just 0. So this is analytic at x is equal to 0. Now let's look at the quantity x minus 0 squared times q of x. This is x squared times 1 over x cubed, and this is 1 over x. This function is not analytic at x is equal to 0. Because this function is not analytic at x is equal to 0, our point x is equal to 0 is called an irregular singular point. And those are our answers. Our answer is that x is equal to 0 is an irregular singular point, and every other point is an ordinary point. And that's it. You now know how to identify and classify ordinary and singular points. You should now be ready to work through some similar problems on your own. If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.